Hi guys, today we're going to learn about increasing and decreasing functions and the first derivative test. In the previous lesson we learned the test for increasing and decreasing functions that says if f prime of x is greater than 0 for all the x's inside the interval ab, then f is going to be increasing on this interval AB. Similarly, if f prime is less than 0 for all the x's inside the interval AB, then what we have is that f is going to be decreasing on this interval AB. So the third condition is that if you have that f prime of x is equal to 0 for all the x's inside the interval AB, then f is constant on the interval, so on the interval AB. So that's what we have as the test for increasing and decreasing functions. Now, what the first derivative test tells you: if you have a c and it's a critical number of the function f that it continues on the open interval I containing c, if f is differentiable on the interval except possibly at c, then what you have is that the point c, f of c can be classified as follows. If f prime of x changes from negative to positive at x equals c, then c, f of c is going to be a relative minimum of the function f. Similarly, if f prime of x changes from positive to negative at x equals c, then what you have is that the point c, f of c is going to be a relative maximum of the function f. So taking account these ideas for the next examples that we're going to work. So in the next example, what you have, they are asking you to find the intervals where f is increasing and decreasing, and they want you to identify all the points that are relative maximums and relative minimums, and of course they want you to justify your answers. So as I was telling you before, when in doubt, take the derivative. So you're going to take the derivative of this piecewise function. Your piecewise function here is linear, therefore the derivative of the first piece is going to be just 2. Please note that here it's not a mistake. I don't know if it's differentiable or not at -1, so I'm here just being careful. So for this one, the derivative of x squared minus 2 is going to be 2x, x greater than -1. So I'm going to leave it like that because I don't want to take any risks with the -1. That's why I don't put the equal. So what was the idea here? Well, what you want is you want to set your f prime equals 0. So first, you know that the 2 is not going to be 0, because you know your number line. Secondly, you have that 2x equal to 0, you have that this happens at 0. So this is going to be one critical number. The other critical number that you have naturally, because of how the function is defined, is going to be the -1. This one, it comes because that's where the piecewise function breaks. So please note, if you have a piecewise function, automatically the breaking points are going to be critical numbers. So what are we going to do here? As usual, as we learn in class, we are going to test from negative infinity to -1, -1 to 0, 0 to infinity. And what we're going to test here is f prime. Please remember that this table, we do it so we can conclude, but if you're in an AP test, they would not count this at all. So select a number in between negative infinity and -1. I would say -2, and plug it in your function. So if you plug it in your function, you know that the derivative at -2 is going to be positive. So you can see that here it's going to be positive. So it's going to be 2 specifically. So here, let's say that you plug a number in between -1 and 0. And we plug -1/2. If you plug -1/2, it's going to be negative, because this is going to be negative, so negative. Then you select a number between 0 and infinity. You can select 1, 10, whatever, right? So what are you going to do? Plug it here. So that's going to be positive. So what's your conclusion here about f? About f here, you know that this is going to be increasing, this is going to be decreasing, and this is going to be increasing as well. So what do you have here? So So increasing, decreasing, and the relative maximum and minimum. Also, you can see that here the function, okay, f prime is changing from positive to negative, negative to positive. So you can see that here you have a relative maximum, here you have a relative minimum. Be careful here because they want the points. Since they want the points, I'm just going to do a mini table, kind of like the ones that you were doing back in Algebra 2. And I'm going to plug my negative 1 and 0 in the original. In the original function, when you plug negative 1, what are you going to have? You're going to have that it's going to be negative 1. In the original function, when you plug 0, you have that this is going to be what? It's going to be negative 2. Okay? So, why? Because I'm plugging the 0 here. Okay? So, and the negative 1 here. Okay? So, that's what I have. So, these are the points anyway. Now, let's conclude. Okay? So, we can say, let's start with increasing. Since what's happening here, f prime is greater than 0, okay, on the intervals negative infinity, comma negative 1, union 0, infinity. Okay, what can we say about f? F is increasing there. So similarly, what do you have here? Okay, since f prime is less than 0 on the interval, and it's going to be negative 1, 0, okay, we can conclude that f is decreasing, okay, there. So I already took care of increasing and decreasing. Now we want to see the points where you have a relative maximum and relative minimum. Okay, so we can say, what can you say here? Since f prime changes, from, let's start with this one, positive to negative, at it was x equals negative 1. What do you know? We know that the point, right? What was the point? Negative 1, is what? Is a relative maximum of f. So please make sure that you state here, or your, let me zoom out so you can see it, that you state f and f prime, very important. Similarly, again, what do you have here? Since f prime changes, from negative, to positive at x equals 0, what do we know? We know, that the point, right, here's 0, negative 2 is what? Is a relative minimum of f. Very important that you say the variable, not the variable, the name of the function, So we justify our answers, and that's it for this problem. What do you think? It's not that bad, right? So let's move on and work on more examples. For this example, they tell you that to use the graph of f prime to first identify intervals on which the graph of f is increasing and decreasing, and estimate the values of x at which the graph of f has a relative maximum or minimum, and justify your answers. So what can you say here? For part A, so let's focus first part A, for which the graph is increasing and decreasing. You know that f prime, for increasing needs to be positive, and for the decreasing f prime needs to be negative. So what you can see here is, let me get here a highlighter, that your f prime is positive above the x-axis. So it's going to be positive here and here. Do you agree with that? So that's the first thing that you see. So what do you know here? F prime, is, you can say, positive, on the intervals, what was it? Negative 3, 1, union, and this one is going to be what? 4, infinity, so, f is increasing there, so you have the increasing. Now the decreasing, what happens here? You can see that when it's negative, your f prime below the x-axis, so you have here and here. So what you can say is that f prime, is negative, on the interval negative infinity, comma negative 3, union 2, comma 4. So f is what? Decreasing there. So you have part A. Cool. Now let's read B. What they want: maximums and minimums. Okay, so what you have here, okay, so the suspicious ones are going to be the intercepts, okay, the x-intercepts here, here, and here. So here you can see that f prime is changing from negative to positive, okay. So what can you say here? Since, okay, f prime, okay, is changing, okay, from negative to positive at x equals, and you can see that this is happening at negative 3. It's also happening here at negative 4, at positive 4, excuse me. So you can put 4. Okay, you can say since it's changing at x equals negative 3 and 4, what can you say? Okay, so you can say that f has a relative minimum there. Please note something very important. You are declaring the f. Okay, similarly what happens here? You're going to tell me what's up with this one. This one is changing from positive green to pink, therefore you have a relative maximum there. So you can say since f prime is changing, or changes, that's fine, okay, from, what was it, positive, okay, so this one, okay, positive to negative at x equals 1, okay, we can say that f has a relative maximum, okay, there. Please note something that is very important here. You don't have the point for the original function f, so do not create it. You don't have enough information to give me the points here. The only thing that you can give me from the original are the x coordinates, okay? So do not create stuff that it's not there. So let's move on to the next one. You have that f prime is less than 0 on the interval negative infinity, negative 3. F prime is greater than 0 on the interval negative 3, 2. F prime is less than 0 on 2 infinity. Okay, so technically speaking, this is the equivalent of our table. Okay, so they are giving you a lot of information about f prime. If g of x is equal to f of x, what is the sign of g prime of negative 1? Okay, so you have that g, okay, prime of x is going to be equal to 2 f prime of x. Do you agree with that? If they are telling you at this one, okay, so let's split this, okay, g prime of negative 1, what's going to be that? G prime of negative 1 is equal to 2 f prime of negative 1. Do you agree with that? So negative 1, where you locate negative 1, it's here, okay, it belongs to that interval. Therefore, you know that this part, okay, is going to be greater than 0. In addition to that, you know that 2 is greater than 0. So what can you conclude? Positive and positive is going to be greater than 0. So, okay, you can say that negative 1 is greater than 0. Okay, so you have that. Now, they redefine g of x, and they define it as f of 3x minus 5. What is the sign of g prime of negative 1? Okay, so here, take the derivative as usual. Okay, when in doubt, take the derivative. Okay, so f prime of 3x minus 5 using the chain rule, and you have that all of this is going to be multiplied by 3. Why by 3? Chain rule. Okay, so then you're like, okay, so let's plug the value. Okay, so you plug the negative 1 here. Okay, so when you plug the negative 1 here, that's going to be what? Negative 8. Okay, because negative 3 minus 5 is negative 8. All of this times 3. Okay, so you know that this 3 is positive, right? But what's up with the negative 8? You have that the f, okay, in the negative 8 is here. So what you see about this one is that that is less than 0. Okay, so you know that this is less than 0, this is greater than 0. So what happens when you multiply a negative and a positive? You have a negative. Okay, so what's the conclusion here? In this situation, your g prime of negative 1 is less than 0. Okay, do you see it? So hopefully you do. Okay, so the next one that we have over here, okay, So you have the function s of t is equal to t squared minus 7t plus 10. This, what it is describing, is the motion of a particle along a line. Okay, so what are they asking you to find here? Find the velocity function of the particle at any time that it's greater or equal than 0. So the first thing that you are going to do is to find the velocity. You know that velocity is going to be equal to the derivative of position. Okay, so what are we going to do? You're going to take the derivative of this one. So you have that it's 2t minus 7. Okay, so that's your velocity. Okay, so then they tell you, hey, identify the intervals in which the particle is moving in the positive direction. Please remember that when you have the situation, okay, you are going to use the same as if you were doing when a function is increasing. So what do you have here? You are going to use your derivative, set it equal to 0. Okay, so what do you have here? You have 2t minus 7 equal to 0. So you solve for t, so you have that it's 7 over 2 or 3.5, whatever you prefer. Okay, and then what are you going to do? Here you are not going to test all the intervals. Your domain is from 0 to infinity. So what we're going to do here in your table is going to be from 0, okay, to 3.5 or 7 over 2, whatever you prefer. It really doesn't matter. Okay, to infinity. Okay, so what are you going to test? You are going to test s prime. Okay, so when you plug any value between 0 and 3.5, okay, let's say 1, what happens to the prime? Okay, so you have that is going to be negative. Okay, and then let's put 4 here. You can that this is positive. Okay, so this is moving to the left. Okay, this is moving to the left, and here it's moving to the right. That's what they were asking. So that's what you have. Cool. So the particle, okay, so the particle, okay, is moving in a positive direction, okay, on the interval 3.5 comma infinity. Okay, because if you want to see, because what was it, s prime is what, greater than 0 there. So that's your conclusion, because it says justify your answer. Okay, now they tell you, hey, identify the intervals in which the particle is moving to a negative direction. Okay, so from the information above the table, what do you have? Since we have that s prime is less than 0 on the interval, and really if you put parentheses or bracket, it really doesn't matter, so just decide what to do. Okay, so since this is happening, what happens? The particle, okay, the particle is moving, okay, in a negative direction, okay, there. Okay, so that's what you have. Cool. Now they are telling you, hey, identify the time intervals at which the particle is changing direction. You know that since it's changing from negative to positive at 3.5, you can say that it's changing direction there. Okay, so the particle, okay, changes direction, okay, direction, okay, at what was it, time t equals, and what was it, seconds? Well, we don't know the units of time. 3.5 units of time. Okay, so the time at which the particle, because what happens is there, because s prime changes, and you can say signs there. So that's what you have. So I hope that you find this video helpful. If you have any questions, please write them in the comments, and I'll see you later. Bye.